In this video we want to cut the single steps out of the whole measurement procedure, so we have only the single stance phase, and then we have the amount of end stance phases which we can build the mean out of it, and that's the target which we're aiming at. So to do that we can use this procedure. I take the sum. At the first point I'm making a plot in this at this step to see the data in there, how much stance phases I've cut it out. Stance phases. Save that one and run the section, and after that, during the section, I include a section break to make the next one to cut out the single stance phases. And for doing that, I build the sum out of this of whole sensors. You can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 stance phases in there. So we should get a mean, and due to the bad conditions during the recording of this GAIT data, we get a pretty large standard deviation, I suppose. So I take the data for cutting. You can name it as you want it, because it's a really bad variable name at this stage. And I take the sum from the data, but keep in mind I take the second dimension, and then I want to look up what I've done and make a plot therefore, and I run this section, and in this plot I should see more than this, hopefully. So what went wrong in this case, I've built the sum of the data in the second dimension, so I should get someone. Okay, perfect. I didn't copy the variable name in here, so my smartphone is busy as well. Sorry for that. And I rerun the section because I've got the same plots, and I maximize the window so that I can look up the data. And what's interesting for me in this case is a certain threshold for the evaluation of the stance phases. So that's a little bit confusing, so zoom out a little bit. But we can see pretty good where the stance phase happens and where the swing phase is, or the stance phase of the other feet, because we have a pretty sharp edge, and we can see, okay, that's the end of this one, and that's the start point of the next step. And I want to investigate in these points and want to make a threshold which is investigating in these points. So we are above, yeah, say 50 or 60. I take 60 for this try. You can adapt it to your code, which will work better. And then I want to look up every point which is above this threshold of 60. Therefore I include another section break, and I want to use the command find to find the position for the cutting of the data. Position for cutting and therefore I use the data for cutting variable. I use the find command, and now we have to say what I want to find. So when the data is less than 60, and I want to get all these points where the data is less than 60, and it delivers back two variables, the position and the value. No Java, and I have assigned it. And then I should get some values. I run this section. Okay, run this section, and I should get an answer here. So perfect. We now see there is 1, 2, 3, 4. So that's because I've looked up every value which is below 60, and this first one are all below 60 in this case, and then this one are below 60, and so on and so on. And what I'm investigating in is this hole in between. So I want to look up where the difference of these values is a large number, and I can find that by using the command diff. So I get the position by using diff. Oh, there are no capital letters. And we rerun this section again. And I get in 1, 1, 1, 1, 1, which is okay because the difference between these numbers here is only 1, so that's fine. And in this vector there is a larger number, so I look up this position, and when I scroll down I should get a large number. Perfect, here is 322. So in between of these points is a large gap, and now I found this gap, and I can again look up that gap by using the command find. What we want to find is in position where the data is greater, in this case than 3. Take that one because it could be that some data is in 2 or something like that, so I put that in and copy that one down, and to don't overwrite it I put a number after this variable, and we run this section and get now the start and end positions of the gaps. So you see we should get about 11 values, not about, it's actually 11. That's perfect because we have 11 stance faces. And in the next video I show how to use that values to cut the data.